Section 7.2.35-T. Assume the random variable x is normally distributed with a mean of 50 and a standard deviation of 7. We want to find the 64th percentile. So when we're talking about the percentile, we need to understand what we're looking for. Now, the 64th percentile means that 64% of the data is less than the random variable x. That is, the area under the normal curve of to the left of x is equal to 0.64. So let's go ahead and draw that. Okay, we know that we're dealing with an area that is equal to 0.64. Okay, we know that our mean is 50, and we know that our standard deviation is 7. So let's draw this picture. So if we have our normal curve, where we know that we have a mean of 50, okay, what we want to do is we want to find a variable, okay, that is 64%, which means it's above the 50% line. We know that we want to look for x, and we know what the area is to the left of this. Okay, and that area is 0.64. And so now we want to find the z-score that is associated with 0.64. And the reason why that we want to do that for part 3, and let's say part 4, we know that the formula for this is going to be x, which is equal to the mean plus the z-score times the standard deviation. So we need to find the z-score that is associated with the area of 0.64. So when we're going to find that, we're going to go and take a look at the areas down here, and we're looking for 0.64. So let's take a look at 0.64. Okay, so we can see that 0.64 is going to be in between those two values. So again, when we use the table, again, we know that the area that we're dealing with is 0.6400. And so which one is it closer to for us to determine which area that we're going to use? Well, the difference between 0.6400 and 0.6368 is 0.0032, and the difference between 0.6406 and 0.6400 is 0.0006, which means it's closer to that area. So we're going to use that area to then determine what our z-score is. So our z-score is going to go all the way to 0.6406, which is 0.36. So therefore, that gives us a z-score of 0.36. Okay, now that we have that, now we can figure out what is the value of x. So recall that x again is going to equal the mean, which we know is 50, plus the z-score, which is 0.36, times the standard deviation, which is 7. So when we multiply that all out and then add the 50, we get 52.52. So therefore, we can say that the 64th percentile is 52.52. Okay, now let's say if we wanted to use the TI-84 calculator. And so what we want to do is we want to be able to find the z-score. So if we want to find the z-score, we need to find the area. So again, we know that the area is equal to 0.64. And we want to find the z-score. And so when you're looking for the z-score, that means that our mean is going to be 0 and our standard deviation is going to be 1. So how do we find the z-score? Well, we're going to find the inverse norm. And so that's INV norm. So we're going to find the z-score to be INV norm with an area of 0.64 with a mean of 0 and a standard deviation of 1. So we're going to go ahead and do that. So second distribution, we're going to go to INV norm. We're going to put in 0.64 as the area. We know that the mean is 0 and the standard deviation is 1. And then you can see that we end up getting 0.36 rounded to 2 decimal places as our z-score. And then once we have that information, then we can go ahead and then plug it into the formula in step 4. Okay. Now, just to see what would happen. Okay. Let's say that if we just let our mean be 50 and our standard deviation be 7. So let's just use that. Okay, so again, second distribution, and then we're going to go to INV norm. And so we know that the area, again, is 0.64, and we know that the mean is 50 and the standard deviation is 7. Okay, as you can see here, we get the value of x. So therefore, if we do that, we automatically get the value of x, which we get down here, which is 52.51. Now, I want you to notice that you get 52.51, which is not the same as 52.52. So you have to convert it to a z-score and then use the formula to get the proper answer, which again would be 50 plus the z-score, which is 0.36 times 7, and that gives you 52.52. Here, it doesn't give you that. It gives you 52.51, so you really need to be careful of just plugging in the numbers into the calculator and just getting that result, because if you plug this into MyMathLab, it's going to be incorrect. So you have to convert it to a z-score and then use the formula. Okay, now how would we use this in StatCrunch? Well, let's do the same thing here. Okay, if we want to use StatCrunch, okay, so let me just open up a new one here. So we go calculators, normal distribution. Okay, so we know that the mean is 0, the standard deviation is going to be 1. And so we know that the area that we have to use once we get to here, which is going to be 0.64, we're going to put in 0.64, and then you should see here that we get the z-score of the following, which is 0.36. Okay? So again, this gives us our z-score of 0.36, and then we would use the formula again, okay, using x, which is equal to mu plus z times the standard deviation. And then I also want you to compare what we would get here. So again, if we use the mean to be 50 and the standard deviation to be 7, and then we calculate that, let's see here, and we know that our area is 0.64, and then we're going to compute, we get 52.51 like we did over here. So again, it's not, unless you convert it to a z-score, you got to be careful. So don't assume that just putting in those numbers is going to get you the exact answer. You got to convert it to a z-score. So again, you're not going to be doing this part here or this part here, but I wanted to make sure you saw the difference.